Hello everyone. In our lessons in this series so far, we have discussed linked list quite a bit. We have seen how we can create a linked list and how we can perform various operations with linked list. Linked lists, as we know, are collections of entities that we call nodes. So far, in all our implementations, we have created linked lists in which each node would contain two fields, one to store data and another to store address of the next node. Let's say we have a linked list of integers here, so I'll fill in some values in data field of each node. Let's assume that these nodes are at addresses 200, 250 and 350 respectively. I'll also fill in the address field in each node. The address field in first node will be the address of second node, which is 250. The address field in second node will be address of third node, which is 350, and address part in third node will be 0 or null. The identity of a linked list that we always keep with us is the address of head node or reference to head node. Let's say we have a variable named head only to store the address of the head node. Remember, this variable named head is only a pointer to the head node. Ideally, we should have named this something like head pointer. It's only pointing to the head node. It's not the head node itself. Head node is this guy, the first node in the linked list. Okay, so right now in the linked list that we are showing here, each node has only one link, a link to the next node. In a real program, node for the linked list that I'm showing here will be defined like this. This is how we have defined nodes so far in all our lessons. We have two fields here, one of type integer to store data and another of type pointer to node, struct node asterisk. I'm calling this field next. When we say linked list, by default we mean such a list that we can also call singly linked list. What we have here is a singly linked list. What we want to talk about in this lesson is idea of a doubly linked list. The idea of a doubly linked list is really simple. In a doubly linked list, each node would have two links, one to the next node and another to the previous node. Programmatically, this is how we will define node for a doubly linked list in C or C++. I have one more field here, which once again is a pointer to node, so I can store the address of a node. I can point to a node using this field, and this field will be used to store the address of the previous node. In a logical representation, I will draw my node like this now. I have one field to store data, one to store address of previous node, and one to store address of next node. Let's say I want to create a doubly linked list of integers. I have created three nodes here. Let's say these nodes are at addresses 400, 600 and 800 respectively. I'll fill in some data. Let's say the cell in the middle in each node is to store data. The rightmost cell is, let's say, to store the address of the next node. So for first node, this field will be 600, which means we have a link like this. For second node, this field will be 800. For third node, this field will be 0. For first node, there is no previous node, so this leftmost cell, which is supposed to contain the address of the previous node, will be 0 or null. The previous node for second node will be 400. And the previous node for the third node is the node at address 600. And of course we will have a variable to store the address of the head node. Okay, so what we have here is a doubly linked list of integers with three nodes. Okay, so with this much you already know doubly linked list. If you have ever implemented a singly linked list, then it should not be very difficult implementing a doubly linked list. One obvious question would be, why would we ever want to create a doubly linked list? What are the advantages or use cases of a doubly linked list? First advantage is that now if we have a pointer to any node, then we can do a forward as well as reverse lookup. With just one pointer, we can look at the current node, the next node, as well as the previous node. I'm showing a pointer named temp here. If temp is a pointer pointing to a node, then temp.next is a pointer pointing to the next node. It's the address of the next node, and temp.previous, or rather temp arrow previous, this is actually a syntactical sugar for tricks temp.prev. So this guy temp arrow prev is previous node, or in pure words, pointer to previous node. The value stored in temp for this example right now is 600, temp.next is 800, and temp.prev is 400. In a singly linked list, there is no way you can look at the previous node with just one pointer. You will have to use an extra pointer to keep track of the previous node. In a lot of scenarios, the ability to look at the previous node makes our life easier. Even implementation of some of the operations like deletion becomes a lot easier. In a singly linked list, to delete a node you would need two pointers, one to the node to be deleted and one to the previous node. But in a doubly linked list, we can do so using only one pointer, the pointer to the node to be deleted. All in all, this ability that we can do a reverse lookup in the linked list is really useful. We can flow through the linked list in both directions. Disadvantage of doubly linked list is that we are having to use extra memory for pointer to previous node. For a linked list of integers, let's say integer takes 4 bytes in a typical architecture, and pointer also takes 4 bytes, pointer variable also takes 4 bytes, then in a singly linked list, each node will be 8 bytes, 4 for data and 4 for link to the next node. In a doubly linked list, each node will be 12 bytes. We will take 4 bytes for data and 8 bytes for links. For a linked list of integers, we will take twice for links than data. With a doubly linked list, we also need to be more careful while resetting links. While inserting or deleting, we need to reset a couple of more links than a singly linked list, and so we are more prone to errors. We will implement doubly linked list in a C program in next lesson. We will write basic operations like traversal, insertion, and deletion. This is it for this lesson. Thanks for watching.